So we've looked at the properties of limit, how to evaluate a limit, and how to evaluate a limit as x is approaching infinity. So as I said, if you are here with me, then when we are done going through this video and the limit of a function, then your quizzes, your exams is rest assured. You are going to score very high marks because basically all the tips that you need is provided here. Now let's talk about one-sided and two-sided limit. And as I said, when I was talking about rational function, we have functions that has been simplified, but when you do direct substitution, it's not working out. For example, if I want to pick limit as x is approaching 1, 2 divided by x minus 1. This is a rational function that when you do direct substitution, it's going to blow up, but we cannot simplify. So what can we do? Then we need to think about the one-sided and two-sided limit. So that is basically what we want to do here. So with one-sided limit, we have two types. We have the right-sided limit. So we have two of them. We have the right-sided limit, which is something like this. Limit x is approaching, let me use a positive, f of x, and we have the left-sided limit. So left-sided limit, this is limit x is approaching a from the left, f of x. So basically, if I have function like this and I have a here, then on the left here becomes the left-sided and here becomes the right-sided. So this becomes the positive and this one becomes the negative. So don't forget, anytime we see something like that, this is telling us that we are approaching x from the positive, this side. And when you see something like this, it means that we are approaching f of x or a from the negative. Is that right? So anytime when you are done, you are doing substitution here, we set s equal to a, not positive a. And here too, we set x to be equal to a, not negative a. So the negative here and the positive here is just the sign that shows us that, okay, we are coming from the left, we are coming from the right. So this is basically one-sided limit. Now, two-sided limit comes in when we conclude. So for example, that I gave limit as x is approaching 1 of 2 divided by x minus 1. For us to conclude on this, whether the limit exists or it does not exist, then we need to check the right-sided, the left-sided, and when we conclude that this and this is the same, then it conclude on the two-sided limit. So the two-sided limit will be like, okay, limit as x is approaching a. So you see that picking the a here is kind of like we are not showing any sign here, which is what we're just doing. Everything that we were doing here from previous video to here was two-sided because we're not having positive and negative signs showing that we are coming from the negative or positive. Now with two-sided, we said this exists if limit as x is approaching a from the positive of f of x is the same as limit as x is approaching a from the negative side of f of x. So that is the two-sided. So for us to conclude on this, this should be the same as this. So that's what we need to know. Now the last one will be, now this limit here, x is approaching a of f of x, does not exist, does not exist. So my does not exist, I'll write it NDE. So when you see NDE in the video, I'm talking about does not exist. Now if limit x is approaching a from the positive of f of x, it's not the same as limit x is approaching a from the negative side of f of x. So these are the things that we need to know under one-sided and two-sided limit. So it's kind of like two-sided depends on one-sided. So function like this, one of the type of function that we need to use one-sided is this. we cannot simplify again. And when we plug it into, we are getting the down to be 0. Then we need to think about one-sided and two-sided. Now, the last thing before we start example is we can have some graphs. I can have 4 of them like this. Okay. So one of the graph can be approaching. So let's assume that this is x. Approaching x from the left. Let's assume that this one goes to top. And then from the right to this one too goes to top. So you see that they are all moving towards the same direction. So we can say that this exists. The limit might exist somewhere because they are all heading towards something. And then let's assume that this is also x is equal to a, and this is going down, and this also going down. Then we can also say that this exists. But the big question comes in. What's the big question that we want to talk about here? The big question comes in when we have something like this. If I have another one here, but now on A from the left, I go down, and then on the right, I go up, then this does not exist. And same thing, if on the left, I go up, and then on the right, I go down, x is equal to this, and then this one too does not exist. So this is basically two-sided. So I look at the negative side, I look at the positive side, negative side, positive side, negative side, positive side, and negative side and positive side. And the other direction is going to tell me whether the limit exists or it does not what exist. Something like that. So yeah, let's take some example to practice, Yeah. So we learned from algebra that if I have magnitude of x is basically having the negative side and the positive side, but we want to modify this small. Now let's assume that f of x is equal to this. This is equal to minus x when all the x values are less than 0. So you see that this becomes negative when x is less than 0. So when x is less than 0, this function is negative. And then when all the values are greater than 0, this becomes positive. So that's one thing that we need to learn from here. So let's start with this one. I have a function. What is this? We want to find the limit as x is approaching f of x from the left. So from the left, since we know this function here, that f of x, since we know that f of x is equal to absolute of x, this is how I did it, minus x, then you pick what's inside the bracket and you say that this should be less than 0, and then x, and you pick the same thing, this is greater than or equal to 0. So coming from the negative means that all the x value are less than 0, like this one. So I have my normal line, I have 0. So this negative is telling us that we are coming from the negative. And all the values here are less than 0. So it means that this is what we are talking about. And the function that we need to use for f of x is minus x. So this is going to give us limit x is approaching 0 from the negative minus x. Right? So that's what we are going to get. Then as I said here, we set x to be equal to 0, not negative 0. So this is going to give us minus 0, and this is equal to 0. So that is the left side limit. Let's look at the right side. So the right side is this side, and you know that anything at the right side of 0 is positive. So it means that here is where x is greater than 0. So we pick this one, and this will be equal to limit x is approaching 0 from the positive of x. And here we set x is equal to 0, and we are going to have 0. So we see that the left is 0 and then the right is 0, which will help us to conclude on C. Now finding the limit as x is approaching 0 without indicating whether it is left or right. So basically we are going to conclude that this is equal to 0 since limit x is approaching 0 from the left of f of x is the same as limit x is approaching 0 from the right of f of x. So this is very cute because all of them, they are equal to 0. So it means that the limit exists and it is equal to 0. Let's pick another example. Right, good. Let's pick another example. Now we have this one here, and we want to find limit as x is approaching minus 2 from the negative side. So anytime we have absolute, then we need to form the piecewise function. So this is called piecewise. So we need to form the piecewise function. So let's start building the piecewise function, right? So this is how I'm going to build the piecewise function. First, I'll start with the function with absolute. So I'll start with x. I start with x minus 2. This is the same as, look at, this is the same as minus x minus 2. So I pick the value, the one in the bracket. So we know that from math 101, plus or minus x minus 2. So this one can have minus x minus 2 and have positive x minus 2, right? So this is what you are going to have. And then we have x minus 2. So that is basically what you are going to have. But we need to have intervals that is going to work with this. Now, the interval for this one is the one in the parenthesis, not this. The one in this absolute here is supposed to be less than 0. So this is less than 0 always. That's how it's supposed to be. So the one in this here is 0 because it's less than 0 because it's minus. So it's less than 0. And then since this one is positive, x minus 2 should be greater than or equal to 0. So that's basically what we just need to do. Is that right? So this is what we're going to do. Now, when I'm done, I'm not done because I need to form the function here. So you can see that the function here is absolute of x minus 2 divided by x minus 2. So I'm going to divide this one by x minus 2. So let's do that. I'm going to have absolute of x minus 2 divided by x minus 2. So I need to do the same thing to this function and this function too. So I'm going to have this, which is minus x minus 2 divided by x minus 2. Then I need to have x minus 2 divided by x minus 2 because I'm dividing this by x minus 2. And then this is going to be simplify this, and I'm going to have x is less than 2. Simplify this, and I'm going to have x is greater than or equal to 2. And guess what happens? Here is the same as this, and it's equal to f of x. So this is the same as f of x, which is equal to the piecewise function. And this will cancel this. So I'm going to have this minus 1, x less than 2, and 1, s is greater than or equal to 2. So this is what I'm going to get, like the function. So this is the hard work. If I'm done going through this, then the rest is just bonus. So now that I've formed this, now I want to find limit. X is approaching 2 from the negative of f of x. So what is the limit as x is approaching 2 from the left? So from the left means that x should be less than 2. So from the left means that x should be less than 2. So the function here is minus 1. So I'm going to have minus 1. Here I'm setting x to be equal to 2. And limit as x is approaching minus 2 is equal to, of minus 1 is still minus 1 because a limit of a constant is the constant. Then I do same for the right hand side, plus f of x. This is equal to limit x is approaching 2 from the positive. Then since it's approaching positive, x value should be greater than 2, and I pick this one, and this is 1, and indeed this is also going to be 1 because a limit of a constant is the constant. So we see that the left is minus 1 and the right is 1. So it means that this limit does not exist since limit x is approaching 2 from the positive of f of x is not the same as limit x is approaching 2 from the negative of f of x. Indeed, this is basically what we are dealing with, negative from the negative side and positive side. Let's pick another one. I think we are enjoying this. Okay, so now this one is like kind of, they've given us the piecewise function. So all the two, we need to form our piecewise function. This one, they've given us the piecewise function and we just need to solve. So this one becomes so easy for us. So let's do that. This is equal to limit x is approaching 0 from the negative. So I need to pick the function that shows that x is less than 0. So the minus here tells me that x is less than 0, right? So which one is x is less than 0? This. So we need to pick this function. So this is x to the power 3 plus 2x plus 1. And then here I need to set x to be equal to 0. So I'm going to have, plug in the 0. I'm going to have 0 cube plus 2 times 0 plus 1, and this will be 0 plus 0 plus 1, and this is 1. So this is from the left. So you see that this is very simple. Let's look at the right. The right is limit x is approaching 0 from the positive. So 0 from the positive means that the x value should be greater than 0. So the one x is greater than 0 is this. So we need to use this one. And then we are going to have x squared plus 2. So what we just need to do here is we need to set x to be equal to 0. The same thing here. And this is going to give us 0 squared plus 2. And this is 0 plus 2. And this is 2. So what will be the conclusion? They are not the same, right? So indeed, this does not exist since limit x is approaching 0 from the negative of f of x is not the same as limit x is approaching 0 from the positive. So you see that it's very simple when you understand it. And I'm sure since you've watched this video, you should be able to do all limit questions and then you are done. Let's look at this one and then I'll give you try example to do. Good. So same idea here. We want to look at limit as x is approaching minus 2 f of x. You see the trick? So instead of the question asking us for the left and the right, the question is asking us this straight away. And you'll be confused asking yourself, what function am I going to use for this? Anytime you have a piecewise function like this, think about the left and then the right. So for me to conclude on A, I need to now solve for limit as x is approaching minus 2 from the left and from the right before I can conclude on this. So I need to look for limit x is approaching minus 2 from the left of f of x, right? So let me just bring it here. And then limit x is approaching minus 2 from the right, f of x. So these are the two things that I need before I can conclude. So this is limit x approaching minus 2 from the left. So from the left means that x is less than minus 2. So x is less than minus 2 is basically this guy. Is that right? So now let's pick it and see. So the function is x plus 2. Now we are going to set x to be equal to minus 2. But look at something here. When I put the minus 2 here, this one is going to blow up. So as I was saying about this thing here, and when we started it, you see when they give you the function like this and it is blowing up, then we need to check the idea. So let's see how we can do this. Now, this is kind of, anytime this is blowing up, it's either we get negative infinity or positive infinity. But this is telling us that since we are picking minus 2 and it's showing us the negative side, it means that we need to pick any value which is less than minus 2. So any value which is less than negative 2 is like negative 3. So when I put negative 3 here, I'm going to have something like 1 divided by minus 3 plus 2, which is 1 divided by minus 1. So this is going to give us minus. And this giving us minus 1 is telling us that this is going to be negative infinity, not negative 1. So this is, when I solve this one, this will blow up to negative infinity. So basically that's what I'm going to get here. So this is going to blow up to negative infinity. Or the other way that you can see this one is you can write this one as 1 divided by minus 2 plus minus 2. And this is coming from the left side. So I can write this one as 1 divided by 0. When I add, I'm going to get 0, but 0 from the negative side. So I put the negative there, telling me that this 0 is actually coming from the negative side, and this is going to give me negative infinity. Good. Now let's look at this one. Let's look at this one. So this is limit x approaching 2 from the positive side. What's the function? 2 from the positive side, we need to look for the value of x that is greater than or equal to negative 2 or greater than 2. So we can see that here x value is greater than minus 2. So this is the function that we are going to use, x squared minus 5. We set x to be equal to 2. So this is going to be 2 squared minus 5. This is 4 minus 5, and this is equal to minus 1. So we can see that the left side is not the same as the right side, because even this one does not exist. So it means that the limit does not exist. This guy here does not exist, period. So basically that's what we just need to do. Last one before we get to the trial example is we want to do this. So same idea, we need to look for limit x is approaching 3 from the negative of f of x, and then we need to also look for limit x is approaching 3 from the positive of f of x. So which function are we going to use for this? X is approaching 3 from the negative. So from the negative means that x values are less than 3. So these are the x values less than 3. So we are using x squared minus 5. So x squared minus 5 sets x to be equal to 3. And we are going to have 3 squared minus 5. And this is 9 minus this, and this is going to give us 4. Now what about this one? Limit x is approaching 3 from the positive side. What function? From the positive side is when x is greater than 3. So we are using this. So let's do that. Square root of 3 plus x plus 13. And here we are going to set x to be equal to 3. So this will be square root of 3 plus 13. And this is square root of 16. And this is 4. So this is 4. This is 4. So it means that the limit here is going to be 4, since limit x is approaching 3 from the positive of f of x is the same as limit x is approaching 3 from the negative side of f of x. Good. So basically this is one-sided and two-sided limit. And if you are done watching this video, you should be able to work around all questions that is in the form of one-sided and two-sided. So let's look at the trial example. Oh, I have last example here. Oh, okay. So let's do the last example, I think, before we get to the trial. Okay. So last example here is very quick. Let me just go through quick. So this is going to be, so this is from the negative side. So this is going to be 1 divided by 3 from the negative side. Let me put it there, minus 3. And this is going to be 1 divided by 0, but the 0 is from the negative side, as I said. So this is going to give us minus infinity. Let's go through positive side. So positive side will be 1 divided by 3 over 3, which is the same as 1 divided by 0, but this one is from the positive side, and this is going to give us positive infinity. So here we are setting x to be equal to 3. Same thing also here, and we just plug it inside the function, because the function is not telling us whether it is the left or the right. So we are using it to solve for the left and the right two at the same time. And then what can we say about this? This does not exist. This does not exist, because even when you look at the graph, as x is equal to 3, so let me just do this. As x is equal to 3, from the left we are going negative infinity, and from the right we are going positive infinity. So it does not exist from here. Let's do last one. Now limit as x is going to infinity. So as x is going to infinity, we are going to have limit as x is approaching infinity 1 divided by x minus 3. We've talked about this, right? Where we talked about when x is approaching infinity. what is the degree of the top? The degree of the top is 0. What the degree of the down? 1. So the degree of the top is less than the degree of the down, so this should move to 0. Or for you to see it this way, you can just plug in infinity, and you have 1 divided by infinity minus 3, and this is 1 divided by a big number minus 3 is still a big number, and this is going to give us 0. Let's look at the minus 1, like the minus infinity aspect. 1 divided by x minus 3. This is going to give us, so this is going to give us negative infinity because this one is odd. So we are going to have something like 1 divided by minus infinity minus 3, and this is still minus infinity, and this is also going to give us 0. The same thing at the end of the day. So basically, this is what we need to get. So take your trial question and work around it. Have this piecewise function, try and find this. So finding this, check the left and the right, and then we are done. Yeah. So as I said, make sure you share the video too as well. You like, you comment, and then share the video with friends. We want to make impact to students that they are struggling with, let's say, limit, calculus, and any other thing. So share the video with your friends, and then see you in the next video.